Consider two real functions, f of x and g of x, continuous at real number c. What can you say about the continuity of the sum, difference, product and quotient of these functions at x is equal to c? Let's begin by checking the continuity of f plus g at x is equal to c. We are given that f of x and g of x are continuous at c, which implies that both f and g are defined at c, and hence their sum is also defined at c. Now, let's find limit of f plus g of x as x approaches c. By the addition property of the algebra of functions, f plus g of x is equal to f of x plus g of x. Also by the algebra of limits, we know that the limit of the sum of two functions is equal to the sum of their limits, and this is equal to f of c plus g of c. Since functions f and g are continuous at x equal to c. Again, by the property of addition of two functions, it can further be written as f plus g of c. This means that the limit of the sum of the functions is continuous at x is equal to c. Hence, the sum of two continuous functions is continuous at x is equal to c. Now, let's check the continuity of the difference of two continuous functions. As f of x and g of x are continuous at c, we have that f of x and g of x are defined at c. Hence, the difference of the functions f of x and g of x is also defined at c. So the limit of f minus g of x as x approaches c can be found. Therefore, f minus g of x can be written as f of x minus g of x. Now, by the theorem on limits, we know that the limit of the difference of two functions is equal to the difference of their limits. So we have limit of f of x as x approaches c minus limit of g of x as x approaches c. Now, since functions f and g are continuous at x is equal to c, we have f of c minus g of c. This is equal to f minus g of c. By the property of subtraction of functions, this means that the limit of the difference of the functions is continuous at c. Hence, f minus g is continuous at x is equal to c. Let's now check the continuity of the product of real functions f of x and g of x continuous at real number c. As f of x and g of x are continuous at c, f of x and g of x are defined at c. Hence, their product is also defined at c. So the limit of f into g of x as x approaches c can be found. Now, by definition, f into g of x can also be written as f of x into g of x. By a theorem on limits, we know that the limit of the product of functions is equal to the product of their limits. So we have limit of f of x as x approaches c into limit of g of x as x approaches c. we are given that functions f and g are continuous at x is equal to c. So the limit of f of x as x approaches c is f of c, and the limit of g of x as x approaches c is g of c. By the property of multiplication of functions, we get f into g of c. This implies that the limit of the product of the functions is continuous. Hence, f into g is continuous at x is equal to c. If function f is a constant function and is equal to k for some real number k, then the product of functions f of x and g of x is equal to k into g of x, which is equal to k into g of x. Since k is a constant and g of x is a continuous function, their product is also continuous. The product of a real valued constant and a continuous function at some real number is also continuous. If k is equal to -1, then minus f is also continuous. This implies that the negative of any continuous function is also continuous. Lastly, let's check the continuity of the quotient of two real functions f of x and g of x at x is equal to c. As f of x and g of x are continuous at c, f of x and g of x are defined at c. Hence, the quotient of the functions f of x and g of x is also defined at c, provided g of c is not equal to 0. Now, by definition, f divided by g of x can also be written as f of x divided by g of x. By a theorem on limits, limit f divided by g of x as x approaches c is equal to limit of f of x as x approaches c divided by limit of g of x as x approaches c. Since functions f and g are continuous at x equal to c, the limit of f of x as x approaches c is f of c, and the limit of g of x as x approaches c is g of c. By the property of quotient of functions, this is further equal to f divided by g of c. Hence, f divided by g is continuous at x is equal to c, provided g of c is not equal to 0. Suppose f is a constant function defined by f of x is equal to k, where k is a real number. Then f of x divided by g of x is equal to k divided by g of x, which is also continuous. Hence, we can say that a real valued number divided by any continuous function at some real number is also continuous. If k is equal to 1, then 1 divided by g of x is also continuous. That is, the reciprocal of a continuous function is also continuous.